my question is that, you know, is there a benchmark for sample size categorization? What I mean is that when is a sample size said to be simple or large?
As you have stated, yeah, so we started with the preamble. Yeah, you say to answer some of this stuff. However, regarding your question, yeah, there are some things that are relative. If you remember when we defined the inductive learning hypothesis, which I say is the basis of machine learning, that says if the data set during the training, if it work on enough sample, it will work on unseen samples later on. So the question is, what is enough? Enough is a fuzzy term. No one says 20 samples or 30 samples. Enough is a fuzzy term. If it work on enough sample, it will work on others. Now, it depends on what kind of information the samples are carrying, actually. You may have samples from a particular problem area that the features are so smart. This is another concept I've often explained in our engagement. You see, sometimes you have a smart feature. If you have smart feature means features that are closely connected to the problem you want to solve. That if you see the characteristics, it can easily indicate that, oh, somebody is poor. Let's say we want to analyze the poor index that we discussed during the last summer training. See, there are some very smart features that can connect you to what you are looking for. Like attendance of students in class. You want to predict if a student will pass a course. If you can have attendance of the student in class or the performance of the student in prerequisite course, this could be smart features that are closely connected to the problem. So in that sense, even though the number of samples you have are not very much, with classification algorithm like support vector machine, you might be able to get appreciable performance measure that is good. But then it depends on which kind of feature they are carrying. Sometimes even data sample could be more, but then after your training, you find out that those features are not smart. So they are not able to really communicate us to arrive at the prediction we want to make. They are not communicating very well. We need to do feature selection to separate the real thing from the charts. The one that are not good, that are just follow, they are just there to make it more features. We have to smartly remove them. So that is it. So the number of samples we need, they are relative. So it depends on how smart, how clean the samples also are. Sometimes you have a lot of sample. Actually, some of them might need to be removed. This is an idea I do propose. When we have data set, we can use unsupervised learning to first of all remove irrelevant data samples. Because sometimes you are having like 500 samples. I can use unsupervised to check. You say this sample belongs to two groups. Poor and not poor group of people. I use my unsupervised learning. I will ask my unsupervised learning to classify this into 3. Please group this data into 3. It will look at them, and then it's able to group them into 230. One group. Another group is 210. Then there are like 10 samples grouped into third samples. Another third group. 230, 210. That is 5. If I'm not mistaken, that is like this is 250. Sorry, you have 250 here. Then this is 240. Yeah. Then they have 10 here. Originally from you, they are supposed to be 2 classes. But now I use one of the methods we can use to check our data set, that are they really good, is to use unsupervised learning to break them into more groups. So when I realized that 250 has been placed here, 240 here, 10 placed at third group, that means these 10, neither here nor here, so they are not good data set. I can remove them from my sample so that my sample can be more smart. See, it means these samples are there by mistake. They might have belonged to this, but they are actually there. The data is not good. I can remove them. I say no. They are going to be contributing nothing except negative to my modeling. So in this sense, we try to use this kind of method to make our data, to strengthen the capability of our data, or the authenticity of our data, if I can use that word. So to answer your question briefly, it depends. So there's no particular number of sample that you can decide that, oh, this sample is enough. No. Yeah. There's no particular sample. We don't work like that. You cannot say it. So that's why we always say, let the data speak. So we are back to let the data speak. The data will indicate whether it is enough or not enough.
A build up to that question.
Yeah.
Okay. Now, this, cost of dimensionality.
Yeah.
Okay. Can we look at it? For instance, if you have a data set of, let's say, 100.
Okay.
Okay. 100 data sample. Okay. Right.
Yeah.
And you have the features, and your features, you have like 40 something features.
Yeah.
Okay. Now, in statistics or econometrics, okay, since these features they represent the explanatory or independent variables.
Yeah.
Okay, it will reduce the degrees of freedom. We call it degrees of freedom. And when the degrees of freedom is too low, for you to estimate the model, it becomes somehow difficult.
Wow.
Okay.
That is exactly what we call cost of dimensionality in machine learning.
Yes, it becomes very difficult. It's very, very difficult.
Yeah.
That means that one is similar to that, right?
Yeah.
Okay. Therefore, in order to overcome this, maybe this problem, you said we should do this feature selection.
Yeah.
Now, and you suggested this in one of your videos. You suggested correlation.
Yeah, use the correlation to check. Very simple one.
To check. Yes, to check.
Yeah.
Now we also have something called principal component analysis.
Yeah. You can also use
principal component analysis to drop some features that some features that have a low factor loading.
Yes.
Okay.
Yes.
Now, I have a student with an ongoing something. Okay, it's not a direct student per se. It's just guiding. Now is conducting a survey, and in the survey, principally in statistics or econometrics, we normally determine in advance the sample size, the expected sample size, because it's going to the field. The survey is ongoing now. Okay, and from the sample size computation we did, okay, we projected that we need at least minimum of 384 data points.
Okay.
Now, 384 data points.
Yeah.
Okay. Now, but it's very difficult now to get to that point.
Okay.
And as at maybe yesterday, we've only reached 118 successful this thing, because there are conditions imposed. Okay, and we've interacted with 12 over 200 students, but only 118 who meet the conditions and successfully completed the questionnaires.
Okay.
Yeah. In this case, if it is under statistics, this is a big problem. Okay, if you cannot meet up with that 384, but can this be overcome when it comes to artificial intelligence?
Actually, thinking what we have just described could be a research question. Actually, how far, or what is the suitability of all these pre-assigned number of samples that you might get? You need to get before you can do a research in the econometry or whatever. Because as far as machine learning is concerned, there's nothing of such. In fact, what I would advise you now is to tell the student to immediately start using machine learning for those 118 projects, 180 data samples. I recommend support vector machine to be used because it has the capability of working on few samples. And you might be surprised that it's able to get very excellent prediction, even though you have not reached this econometric stated number. Yeah. These are some of the table shaking idea that machine learning is bringing on top now. See, we want to really let the data speak. Yeah, these are the old method of doing things. Now things have really changed, Prof. Yeah. So I can assure you, let the student use machine learning. With the 180, in those days, I know he's going to be in big trouble because he's not able to get the number of data. But this boy has no control over people who respond to his data. So with machine learning, I think machine learning can come to the head of this kind of student, because machine learning can be able to get reasonable prediction with the data set he's having, even though he has not been able to satisfy the econometry imposed condition. That's why I say it could be a collaborative research effort to investigate the impact and the effect of the preset condition from econometric point of view on the applicability of machine learning to this kind of problem. I hope you understand my point.
Okay, thank you, sir.
Thank you.
Yeah. Please, this, the target variable.
Yeah.
Okay. You said originally support vector machine was designed to undo binary target variable.
Yeah.
Okay.
Classification.
And later on, it was upgraded to undo, multi categories of, target variable.
Yeah, classification. Yeah, this classification.
Yes, classification, right?
Yeah.
Okay. Now, there is, in statistics or econometrics, okay?
Yeah.
Most especially one is working in the environment of logistic regression.
Okay.
Now, there is a difference between ordered category and unordered category. What I mean by ordered is that, take for instance, if you are dealing with a grade level, for instance, if you say first class, second class, this, that, maybe you want to predict whether a student will have first class, whether they will have second class, upper, second class, lower. You can see they are in levels, they are ordered.
Okay.
And if this is our target variable, if this is a target variable, it's different from saying that we are investigating a problem where the target variable is an ordered category. Saying that we can say maybe a student will go to school, a student will attend a particular private school. This one will attend public school. This one will attend maybe special school. The one is not higher than the other. It's a matter of choice.
Okay.
One is not higher than the other. It's a matter of choice. The way we treat it, that one is an unordered.
Yeah.
This is an unordered target variable.
Yeah.
But the one I stated the example is ordered because their one level is higher than the other.
Okay.
And the way it will be treated, it will be different.
Yeah.
When we be what? We'll be estimating the logistic regression, it will be different.
Okay.
Is it similar thing applicable under machine learning? Or it will just be nothing like that?
No, the good news in machine learning is that just let the data speak. If you can provide me with the data set of previous incidents of the first case or the second case, we don't care that it's harder or it is not harder. Our system will work for it. Yeah.
Okay.
Yeah. It has a unique way it works for everything. Once the data is there from the historical perspective, it will work.
But please, this hyperparameter tuning.
Okay.
The hyperparameter, even though you did not mention it, is it the same as a sensitivity analysis?
Well, the hyperparameter tuning is not the same as sensitivity analysis, but sometimes also could be linked with it because there's a method called sensitivity analysis. So trying to see the sensitivity analysis can be approached from different perspectives. You can look at it from the perspective of the feature that are involved also. Okay. So that's why sensitivity analysis is it can be looked at from different angles. That's why we cannot equate hyperparameter tuning to sensitivity analysis.
In determining the performance of the model.
Yes.
Hello?
Yes, I'm with you.
Yeah. In determining the performance of the model.
Yes, sir.
Are we focusing on only the fit, maybe the R square, or there are basic, indicators? of determining the performance of our model.
Thank you. Well, if you want, there was one. I really believe that we have been some of our earlier videos where we discuss evaluating models. We discuss some of the. It depends on the model you are building. If you are building classification model, yes or no, or ordered, as you just mentioned, and non-ordered. Yeah, these are classification problem. Then we have set of standard measures, like accuracy is one of them, like precision. You will ask confusion matrix to see where the false positive, false negative. However, if you are working with the target variable that is a regression, that you want to predict numbers, actual values, what is the mark of student in the final exam, things like this. In that case, we will not be using accuracy, but we'll use R square, as you mentioned. Coefficient of regression, I mean, the R square.
Professional determination.
The determination, thank you. Then we have the root mean square error, very popular one. Root mean square error. This is where we are going to be looking at the actual difference between what you are predicted and what is the expected. The root mean square error. And also we can plot it on a graph. Plot the predicted on the actual. You can see the difference in the position of the actual and the prediction. So you can see how close they are together. These are the performance measure, different that depending on the problem you are solving. If you are the first one to solve that problem, then you can come up with what are the measures you think will be more appropriate. However, if people have solved that problem before, then you have to look at the paper and then bring on board those measures that they have established as the most preferred in that area, because it's not general. For example, if you are doing prediction for software engineering, effort estimation and the likes on software development, we have some set of special measures that they don't use in other areas because of the interpretation. So this is how we treat it. There's some standard that is across board, like root mean square error is used anywhere. R square is used anywhere. They're very popular. Accuracy and then the confusion matrix also is used everywhere for the classification problem. However, some problem area, they have special measures. Then we have to look at the literatures in those areas and identify the appropriate ones to be used. I hope that is clear, bro.
It's clear. Yeah, please, we are explaining something in the data, okay?
Yeah.
Since we have large number of features, and when we developed the Google form, it was not originally, we did not assign values to the options from the beginning. Therefore, it returns, if it is male, it will return male in the data set, male, female, you know, it will return single, married in the data set. All right. I want to ask, is it a must to always convert everything or assign numerical values to our data before we load it into the Weka environment? Is it a must?
No.
Or can
No, it's not a must. Yes, Weka can work. The only thing that is compulsory is the target value. If your target value in Weka is 1, 2, 3, it will treat your problem as a regression problem. It will not treat as classification, even though you want it to be classification. You get the point. So you have to convert your target value to be yes or no, yes or no, yes, no, yes, no. However, for the values, for the features, it can be number, it can be anything, it can be value, whatever. Yeah, it's okay. You don't need to convert them. But the target value, if it is regression, it has to be number for sure. But sometimes when you have classification problem, people use 1 for yes, is 0 for no. Weka will not accept that for you. You have to convert that 1 to yes, Y-E-S,
good,
and 0 to N-O, no. Otherwise, it will treat it as a regression problem, which will be a wrong result. But the features can come with any value, either number or whatever. You don't need to convert. Yeah.
Okay. The analysis will proceed without conversion.
Yeah, without any conversion.
Okay. Now, this classification in your submission today, during your lecture, you said we have 2 options for the partitioning, data partitioning. Okay, that we can partition the data into two. We should have the training set and the testing set, or we partition into three. We have the training set, we have the validation test, set, we have, and the testing set. Now, based on experience and what is dominant in the literature, which one will give a better result?
Well, it depends. The idea is if your data set is small, like this kind of student now is having very few data set, so dividing into training and testing should be enough. You get the point now, okay? Or if you have sizable number of data set, then you divide into three is better, because the idea is that you make sure that during the training you don't use the testing set for the hyperparameters checking. You get the point now. Or the hyperparameter checking should be done on the training set, while the testing set is kept separate. Are you with me? Okay.
Yes, sir.
This is the idea, so that we don't bias the data. Because if you when you are checking for the hyperparameter and you are using the testing set, then that means we are shifting towards a kind of hyperparameter that will be good for the testing set. It's like we have seen the testing set. This is the idea. So if the data is enough, divide to three is better. Otherwise, divide into two, but focus on using the training set to establish the hyperparameter.
I noticed in the lecture you gave today, the hyperplane is linear. So, and you did say that the advantage of the support vector machine is that even when the data, I don't know, pardon me, you know,
yeah,
this is my first time of using this.
Okay, go ahead. That's okay.
So yeah. If we cannot classify linearly, then we can push the data to higher dimension.
Yeah.
So I'm thinking I was thinking that I think there may be cases of non-linear hyperplanes. So the question now is, between non-linear hyperplane, let's say I have a data.
Okay.
How do I make a choice of, okay, should I go for non-linear hyperplane or should I push it to a higher dimension? Which one is more effective? Because you said no matter how the data is, if we keep pushing to higher dimension, we can always get a linear hyperplane that separates these two classes.
Yes.
So,
yeah, thank you very much. Thank you. Thank you, Doctor. So it's a pleasure having you on board also. And thank you for the very interesting question, which indicated that you are actually really listening rapidly to the lecture. Yeah, those are the two secrets of support vector machine, having that capability to push to a higher dimension. If it becomes not separable at lower level, it keep pushing. Let me show you a kind of a scenario. I hope I have that scenario here, whereby we keep, look at this scenario, Doctor.
Okay.
This is one scenario here where this was the normal thing. When you push it to higher dimension, it was one dimensional, it become two dimensional. Now we can separate. Support vector machine, unfortunately, only work with linear hyperplane. It can only break into two places. Yes or no. Yes or no. That is a weakness of support vector machine. It cannot handle even three classes at a time. Only two at a time. So it can only draw a line that separates two classes. So if it cannot do that here now, you might need a non-linear hyperplane, maybe like a circle, to separate this guy from red and red here. But no, it doesn't work for support vector machine. It has to push it to a place that a line can be possible like this. Look at another case here. You see here, you can see, we cannot even separate with this kind of curve. No, it's not allowed. It has to be a line. So if a line is not possible, it will use a kernel function to push it so that it becomes separable with a line.
Okay.
At some point, look at this case. You can see look at the blue, look at the red. Here, this is two-dimensional. We push it to three-dimensional. You can see at three-dimensional, the separation becomes possible with a line. This is the idea.
This is an hyperplane in two dimensions.
Thank you very much. Yeah. Yeah. So that is it. Look at this one now. You can look at this. Look at how complicated it becomes. It cannot separate it. When you put it to a kernel, then you can see the decisions of it against become stable here. See here up, why this one are down, you can draw a separating hyperplane for them. To you. I hope that clarifies. So until next week, inshallah, when we're going to meet again. So we say thank you very much for attending. Do remember to check out the earlier videos on the support vector machine already in our YouTube channel. And do invite others also to benefit from such videos. They are free to join our weekly classes. Also, they can subscribe to our YouTube channel so that more benefit could be given to others. Thank you very much.